Now I start about acceleration and velocity time graph. What is acceleration? Acceleration means something will be accelerate, like increasing. And what will be accelerate? You see when you drive your vehicles or your parents drive any vehicles, then they accelerate. They use accelerator. That accelerator to increasing the speed of the vehicle. From that term, we can define acceleration, the rate of change in velocity, with respect to time. The rate of change in velocity with respect to time is defined as a acceleration. The rate of change in velocity with respect to time is defined as a acceleration. From here we can say that acceleration is defined as the change in velocity with respect to time. Or we can say that ratio of change in velocity to the change in time is defined as an acceleration. It is represented by small a. It is a vector quantity. Vector quantity means the quantity which have direction and magnitude both. If we increase the speed from 10 km per hour to 20 km per hour, then 1 second, then the acceleration is 20 minus 10 upon 1. Then this acceleration is a vector quantity and its SI unit is, what is the SI unit of velocity? Meter per second. Then meter per second upon second, acceleration is meter per second square. The SI unit of acceleration is meter per second square. Now, deceleration or retardation, the opposite reciprocal of the acceleration or deceleration. Deceleration means negative acceleration. If acceleration is positive, then this is known as acceleration. If acceleration is negative, like using brake. When we using brake, then we retarded the speed of the vehicles, we retarded the speed of cycle or bike. Formula is same, A is equal to B minus U upon T, but in this case A is negative. When A is negative, in this formula, when A can be negative, when B is less than U. In the case of is V less than U means initial speed is more than the final speed, then we called acceleration as a retardation or deceleration. Both formula are same, both are vector quantity and both have same unit, that is SI unit is meter per second square. You have to remember what is the difference between distance, displacement, velocity, speed, and acceleration and retardation. Now the next topic is velocity time graph. Velocity time graph means if you plot a graph between velocity and time, when velocity is always along y-axis, time is always along x-axis, then this graph is known as a velocity time graph. Then velocity time graph is of many ways. There are many ways by which we plot the velocity time graph. From those six of velocity time graph. First graph shows when there is no acceleration. If there is no acceleration means there is no change in the velocity. If speed of the body or velocity of the body remains constant, there is no change in magnitude as well as direction, then the graph is parallel to x-axis. Here velocity is along y-axis, time is along x-axis, and if graph is parallel to time axis, then this graph represents slope is 0. If slope is 0, then acceleration will be 0. From distance time graph, we can find speed. From distance time graph, we can find speed by taking slope of that graph. But from velocity time graph, we can calculate distance as well as acceleration both. From velocity time graph, distance can never be zero because this distance is equal to area of the covered graph. From this figure, if we take area of this graph, area of this rectangle, that rectangle, area of rectangle is equal to distance. From velocity time graph, we can calculate distance as well as acceleration. But in this graph, there is no acceleration, there is only distance. And distance can never be zero in velocity time graph. Second graph represents again velocity is along y-axis, time is along x-axis. This graph represents a straight line passes from the origin. A straight line passing from the origin O. It means it has some slope. The slope of this graph represents acceleration. The slope of this graph represents acceleration. And that acceleration is equal to slope of this graph. And this is a straight line, therefore your acceleration is also uniform. If we get a straight line passing from the origin but not parallel to time, not parallel to velocity, this shows uniform acceleration. Here the graph passes from origin, then u is equal to 0. In another graph, again we plot a graph between velocity and time, but this graph starts from some point A. This graph is not from the origin O, and if the origin is not there, then there is some initial velocity because at this time there is velocity. At A point there is certain velocity. This initial velocity is represented by u, means the body starts from initial velocity u. And we get a straight line, it means uniform acceleration. And in this graph, the slope of the graph slope of the graph is represented the acceleration. Here we also have uniform acceleration, but u is not equal to 0 because the graph is not starts from the origin, not from the 0. This uniform acceleration shows at every point between A and B we get constant acceleration. Now another graph is, this is also velocity time graph, but this is not a straight line, not parallel to time, not parallel to velocity. Then from this graph we can say this is a curved line, or velocity increases with respect to time. Velocity is not directly proportional to time. This is increases with respect to time, which shows increasing acceleration. There is increasing acceleration. In this graph, velocity time graph, there is also curved line. This curved line shows velocity decreases but not directly proportional to time. This decreases with respect to time, which graph shows decreasing acceleration. In this case, decreasing acceleration. In this case, increasing acceleration. We can't calculate acceleration at these points because there is not, slope is not fixed. Slope is changes with respect to time. At different points the slope is different. Therefore we can't calculate the acceleration in this graph. We can accelerate the graph acceleration, we can calculate acceleration only in those graphs where slope is constant. Okay students, now in the last graph there is also velocity time graph. Initial velocity is u, final velocity is v. Initial velocity is a and final velocity is v. If this initial velocity is u, if this initial velocity is u at a point and final velocity will be 0. In this figure, initial velocity is u and final velocity is v, which is 0. It means graph is a straight line, definitely straight line, but final velocity will be less than u. Therefore, this is a deceleration or retardation. This graph shows negative acceleration or retardation. Here we also find the value of acceleration by taking slope. This is also slope. This is also slope. We can calculate distance by taking this slope. This slope is equal to acceleration of the graph, but this acceleration is negative because velocity is 0 and u is not 0. Final velocity is less than u. Therefore, this graph shows negative acceleration. Then from this graph we can calculate acceleration. From last graph this is negative acceleration. From first graph there is 0 acceleration because slope is 0. In second graph acceleration is some. This is not 0, not maximum. In second graph also we have some acceleration which is constant because slope is not changing from A to B. Okay students, thank you.